Hi, today we're gonna find the end in a batch reactor, which basically means using the integral method to find the order of reaction for a batch reactor under irreversible reaction. So some of the basic things we should know before we use the integral method is to know the integrated forms of the design equation, how to derive them, and how gradient plays a part. So this will be the integrated forms of the design equation for 0, first, second order, where n equals to 0, first, and 2. So it is arranged in a y equals to mx plus c format. This is your y for the respective order of reaction. And where y equals to concentration, x equals to time. So y gradient. If an correct order of reaction equation is applied to a set of values, a straight line would be plotted, thus having a constant gradient where dy dx equals to constant. So for example, if I have a second order reaction and its concentration and time are given to me, if I plot against these equation, I would get a straight line, which means I will get constant gradient. So the steps to do it, we have to change the respective concentration values into their integrated form y by the order of reaction, which is basically these Ca ln Cn 1 over Ca, depending on the order of reaction. Then we have to find the gradient, and we have to find the consistency of the gradient for a given set of value. I have done up a table for you to see. So yes, this is just sketch. This is your concentration, your time, and your derived y values for your 0 order, first order, and second order. So the next step would be to derive the gradient between intervals of each concentration. This may look familiar, something like y1 minus y2 over x1 minus x2 to get a gradient, but in this case it's 1 over concentration of A1 and minus 1 over concentration 2 over x1 minus x2 equals to gradient 1. Then you can derive a gradient 2 and a gradient 3. Notice I get a gradient from interval, 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 and interval. So for concentration, I get 3 gradients. And if the gradients are consistent or with accuracy of 0.001, that will indicate your order of reaction. And for exam questions, I think the time will usually be in the correct interval, maybe intervals of 5 minutes, 1 minute. So the real main thing you should concentrate on is the deriving of the y values. So you get a ln and everything. So I'll tell you, if your first 3 values are the same, most likely that would be your order of reaction. So I've come to the end of my video presentation. I hope you know how to find the order of reaction for a design for a batch reactor. Thank you.